In this video, we're going to be looking at multiplying and dividing rational expressions. That's a big fancy word for fractions. So you have to go back and remember, how did you learn to multiply fractions way back in elementary school? Well, first of all, you remember that when you divide, you have to take the reciprocal and multiply. But let's look at the directions you're going to see in your workbook. It's going to say perform the indicated operations and reduce to lowest terms. Well, even though the indicated operations are multiplication, like that, and division, like that, you're really not multiplying and dividing. Your objective is to factor and reduce. And amidst that factoring and reducing, we actually will be doing some multiplying and dividing. Let's look at this first problem. I want you to notice in this first problem we are multiplying and dividing a lot of monomials. Monomial means you have one term. You should not see any addition and subtraction signs, which makes it a lot easier, so that factoring we really don't need to worry about. So let's just look at, would I just start multiplying? Well, no, I need to take care of that division. So let's just go ahead and rewrite this problem. And when you're writing it out, you might want to just give yourself a little extra room. And remember, this is like over 1. Now, since we're dividing by that last fraction, we're going to multiply by the reciprocal. So notice I've kind of given me a lot of space. Now we're going to go back to how you learned how to reduce just fractions, the numbers. Remember, you can reduce anything with a numerator with a denominator that has a common factor. So I always like to just kind of start at the beginning, 10, and I look at the bottom and I go, well, 9 and 10 don't have a common factor, but 4 and 10 do. They're both divisible by 2, so I'm going to reduce these by 2. And then again I look at 5 and 9, no, so keep going. Then I get the 18. Well, 18 and 2 are divisible, but 18 and 9. So you can kind of choose. So 9 goes into 9 once, that goes into there twice. But now I see 2 goes into 2 one time. And so really the only thing I've got left on top as far as numbers is I have a 5, I now have a 1, and I have a 3. And on bottom I just have a lot of 1s. And at this point you have a choice. You can start reducing the letters, which some people do, and I have done that in the past. But since I have all these M's and P's and X's and Y's all over, I'm going to kind of condense it first. So I'm going to take care of my numbers. 5 times 1 times 3 is 15, and then I just have 1 on the bottom. Now how am I going to start condensing? I'm going to take these M's and combine those, and remember, keep the base, add the exponent, so that would be m to the 8th. P's, keep the base and add those exponents, remember that's a 1, so that's also to the 8th. And then I have x to the 5th y cubed. On the bottom I have x cubed and x squared, keep the base, add the exponents. Y's, remember that's y to the 1st, so keep the base and add the exponent. So I've kind of condensed my letters all in one place, so I'm not kind of looking across my paper and seeing all these canceling out problems. Now can I reduce here? Yes, you can. So notice you have x's are the same base and they have the same exponent, so those just divide evenly, as in x to the 5th divided by x to the 5th is 1. Or you can say they cancel. And so do the y's. So my final answer is 15 m to the 8th and p to the 8th. So monomials are a little bit easier. You're just using your properties of exponents and properties of just regular fractions that you learned and how to reduce those. So will it get more difficult? Yes, it will. If we look at the second example, you should see binomials because we have plus and minus signs. So that means we can't just start canceling things out. We have to factor in order to reduce. And hopefully you also notice that I have division, which means I have to change that to multiplication by the reciprocal. So let's just do that step first. Let's rewrite this as multiplication and put the denominator up top and the numerator in the bottom. Now let's talk about factoring. Can you factor 4 minus x? No, you cannot, so it stays just like it is, and we're going to put parentheses around it to remind us that that is indeed a factor, and you can only cancel out like factors. On the bottom, how do you factor that? A GCF of 3. So 3 times 2x is 6x, and 3 times 3 is 9. On the top here, I see a GCF of a z. And on the bottom, another GCF of 5. So now that I have factored everything possible, I can cancel or reduce common factors. So hopefully you see 2x plus 3, you go, yep, that divides out, leaves a positive 1. Do you see anything else? Well, those look almost the same. Those are not the same, but they are opposites. And in the previous video, we talked about how to reduce opposites. They don't divide and leave a positive 1. When you divide them out, they leave a factor of negative 1. And again, you can leave that negative 1 on top or bottom, just not both. My habit is to leave it up top. So my answer is negative 1 times z. And on the bottom, all I have left is 3 times 5, which is 15. So I actually did do some multiplication, but it's not really till the end. So the directions are a bit misleading. You've got to know to factor and then reduce. This third example, we don't see binomials, we see trinomials. And binomials, I guess, and I still have to factor. So this time we have a multiplication, so I don't need to take the reciprocal of anything. But I know I'm going to do a lot of factoring. So I could start here, then here, then here, then here. But here's a suggestion. Pick what looks easiest for you. Pick what you know how to factor. Well, I think this is the easiest for me because it's a trinomial with a coefficient of 1. So I know I need to have 2 parentheses and I need x times x, and I just need to say what multiplies to get negative 10 but adds to get negative 3. And that's a negative 5 and a positive 2. And then what I think is easiest next would be this one because it's just a binomial. It's not the difference of squares. It just has a big O GCF of, let's see, 7 and x, right? So 7, if I divide both of those by 7x, that's going to leave me 3 minus x. Now, these two look about the same. So I'm going to just take the top one. So I know it's a trinomial. I know that 2 times 1 is 2. And for 15, I have 3 times 5, or 1 in 15. And I always like to try the 3 and the 5. And this is where you can use the other parts of the problem to maybe help you make a guess. You know, you're trying to maybe cancel stuff out. So as I look down here, I have an x and a 3 together. So I'm going to try this 3 with that x. It may or may not be right, so I'm going to try the 5 here. And remember, I want a negative 1 in the middle. So that's going to be 5x. That times that is 6x. I make that negative and that positive. That's going to give me that negative 1x there and a negative 15. Now let's look at that trinomial. So again, I know 2 times 1 is 2, and my choices for 10 are either 1 and 10 or 2 and 5. Well, since I have all these 2's and 5's up here, I'm going to try 2 and 5. Also remember, you can't put a 2 with a 2, so I'm going to put the 5 here and the 2 here. And that also kind of matches up. I have an x and a 2, an x and a 2, so maybe that ends up canceling. I don't know yet. And that kind of matches. And since all of those are positive, then my signs are all positive. And again, let's check that middle term. That's 5x, that's 4x, and if they're both positive, I would get 9x. So I have now factored. Now I want to look for any common factors from the numerator and the denominator. Well, hopefully one's just kind of glaring at you, 2x plus 5 and 2x plus 5. What else do we see? X plus 2 and x plus 2. That's good. And then we have this x minus 3 and 3 minus x. And one more time, those are opposites, so those reduce, but it leaves a factor of -1. Don't lose that -1. And I don't see anything else. And so this is where you have to be really careful on your paper. Make sure you spread things out so you don't lose stuff. You see a lot of markings. I'm going to go through and say I have this and this in the numerator, and that is the only thing I have left in the denominator. I don't want to lose any of that as I write my answer. Okay, so on top I have -1 times x minus 5 divided by 7x. Now that's an okay answer, but you're never going to see that -1. You're probably just going to see a negative and then an x minus 5 over 7x. And that's okay. I'm going to give you some other choices. You could also have x minus 5 on the top, and if you felt like it, you could put that negative on the bottom. One more option. You could distribute that negative on top and write it like that. All of those are correct. So let me show you what would be wrong. Wrong would be this. That's wrong. This negative needs to go to both, and here that negative is only for the x, so that would be incorrect. So the safest thing to do is make sure those factors are in parentheses. Can't go wrong. So just to recap, when you see these directions, perform the indicated operations and reduce to lowest terms, you've got to look and see what kind of operations you have. If you've got multiplication and division, you need to remember to factor, 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 and then reduce any common factors.